Okay, so let's look at the substitution reaction for alkenes. And the way this works is that we're going to have an alkane molecule being reacted with either chlorine or bromine. Okay, so now if I take CH4 as an example, so you'll have this structure, and when you react it with chlorine, so how does this work? So what's going to happen is that this chlorine molecule, or you can say any one of these chlorine molecules, now are going to react and removing this hydrogen and taking place of this hydrogen. So what's going to happen in the reaction is that one of the hydrogen molecules from this CH4, it can be this one, 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 it can be any hydrogen molecule. It is going to get separated, it is going to get replaced with a chlorine molecule. So let's see here. Now the fourth hydrogen that was here, this one gets replaced with a chlorine molecule from here. Okay, so this doesn't look like this anymore. It's going to look something like this. It's going to look something like this. Okay, and plus, what further will you have? So you removed a hydrogen from here and you reacted this chlorine and formed or attached it with the alkane molecule. Now you have a hydrogen here and you have one remaining Cl molecule here. So these two will combine to form an HCl molecule. Okay, so this is going to be your products. And if I write it cleanly again, so the overall structural equation looks something like this. Plus chlorine molecule, or you can also write it like this. Yeah. And you're going to have a chlorine plus an HCl molecule. And this reaction, you need to know all the reactants and the products are going to be in a gaseous state. So the overall equation for this is going to look something like this. CH4 in gas, chlorine in gas, and one more thing, yeah, this reaction is going to proceed under UV light. It cannot happen without the UV light. This is a very important point, and I think you'll be avoided a mark or two at times for just knowing that this reaction happens under UV light. Okay, so this becomes CH3 Cl. Why? Because it was CH4 here. But since we remove a hydrogen and place the chlorine, so this becomes CH3Cl, and that too in a gaseous state, plus an HCl in a gaseous state as well. Okay, so this is your reaction equation. But the interesting part here is that this doesn't stop here. So this reaction can proceed until and unless all of these hydrogens are removed. So you have total of 4 hydrogens. So a total of 4 hydrogens. So a total of 4 reactions can take place. Let's look at it. How? So if I take it again, so you need to know that this here were the reactants, okay, and these were the products. But when you continue this reaction, what's going to happen that this product part is going to become the reactants for the next equation, which is this, plus again a chlorine molecule in gas. And what's going to happen again? This is going to happen in UV light. So the same thing happens here, but what does the structure look like? So this was CH3. So what's CH3? Cl plus a chlorine and a chlorine. Okay. And then what's going to happen again is that this chlorine molecule now, or this any chlorine molecule, is going to take place of any of these 3 hydrogen molecules. It can be any of them. So let me take this one for example. So now you have removed 2 chlorine molecules in 2 reactions. And again, you removed one hydrogen, you had a chlorine in spare, so this makes it an HCl again. And this is your again a reaction equation, and all of this again happen under UV light, and all of the molecules are going to be in a gaseous state. Okay, so how does the reaction equation looks like? So CH3, okay, we already had it above, so we don't need to do it again. Yeah, so here it's going to become CH2 Cl2 gas plus HCl, and this is how the reaction equation is going to look like. Okay, now let's further continue the reaction. Now let's take it with, because we say now this part is going to become the reactant for next equation. You still have two hydrogens left. So now this is CH2 Cl2 in gas plus chlorine and chlorine. You can write it the chlorine. You can write chlorine either way. You can write it as Cl2 gas. You can write, and you can also write it this structured way. Okay. So this is now again what's going to happen. Another chlorine, this chlorine molecule is going to remove another hydrogen molecule. So let's say we have it here, and now you have successfully removed three hydrogens. And since you have one hydrogen and one chlorine in spare, now this becomes an HCl. Again, all of this is going to happen in a gaseous state, and the reaction equation is going to look something like this. So CH2 Cl2 gas plus Cl2 gas. It's going to happen under UV light, don't forget this. And then it makes CH and Cl3 in gas plus HCl. Okay, now again, there is one more equation left. So now you only have one hydrogen left. You can simply remove this, it's the same way. So here, if I draw the structure, so this is the structure. Oh, sorry, no. These were the chlorines. My bad. Right. So this is a chlorine here, this is a chlorine here, and this is also a chlorine here. And you have a hydrogen here, which reacts with a Cl2 in a gaseous state under UV light, and it makes what? It removes the last hydrogen molecule as well. Right? Oh, sorry, my brain is not braining at the moment, and that's why I am making these mistakes. Yeah, so now you have a Cl here, and a Cl here. And you have an HCl here. So how does the equation look like? The equation looks something like this. CHCl3 in gas reacts with chlorine in gas, and it forms a CCl4 that is also in gas plus HCl in a gaseous state. And this reaction happens under UV light. So this is all the reaction equations and how the reaction proceeds in substitution reactions. And you can also do this for bromine as well. So let me just make one for bromine, and let me make it with any other different molecule than methane. Let's take ethane for example. C2H6. Now you'll only be able to do this with two different halogens, which is chlorine and bromine, and these are called halogens. Okay, these are called what? These are called halogens, right? And if I react with it Br2, and what do I do? Let's make the structure first, which is 2C, and here you have this. Yeah, and you have a Br molecule, right? Yeah, and this is going to form. What's going to happen again? The same thing. This Br is going to remove any of these hydrogens, any of these hydrogens. Okay, so let me remove this one. Okay, so this count becomes, mhm. So this becomes Br, and then you have an H. Okay, and now since you have an hydrogen molecule and a Br molecule, this is going to form an HBr molecule. So yeah, there's one more catch. This happens under UV light. This is something that we know, but this here is going to be an gaseous state. The products are going to be in a gaseous state, but you need to know that bromine, it exists as a liquid. Okay, it does not exist as a gas. At room temperature, bromine exists as liquid, and this is also going to be a gaseous state. So there's only one differentiation, that chlorine exists as a gas and bromine exists as a liquid. Okay, so if I write the reaction equation, it's going to look something like this: C2H6 in a gaseous state react with Br2 in a liquid state, and it's going to form what? It's going to form CH3 CH2 Br in a gaseous state plus HBr in gas. Okay, and you can also continue the same reaction. Let me do this for just one more. So if I continue the reaction, this becomes the reactant. Sorry, just this part. Mhm. Yeah, this becomes the reactant. So this is CH3 CH2 Br in gas, which reacts with the bromine molecule, which is in liquid. Okay, so what happens here again? So if you see the structure again, which looks something like this. This is a Br and an H and an H. So what's going to happen? Now there are two bromine molecules. One of these bromine molecules is going to attack one of these hydrogens and is going to replace it. Okay, so it can replace any hydrogen here. Okay, it can replace any of the hydrogens here. So how do we do this? So this is, hello. Yeah, sure. Mm, I think I'll say around 4:30, 4:40. I'm just heading out, so I'll be back in an hour. Oh god. Okay. So what's going to happen? Now this bromine molecule, since it will replace one of the hydrogens, it's going to look something like this. Okay, C H N H and C H. You have a Br here, and you have a Br here, and you can also, this can also be, by the way, like this. There is no hard and fast rule on where to attach the bromine or where to attach a chlorine, right? You can attach it anywhere you like. Okay, so this is how this works. And yeah, one more important thing that you guys need to know, and that is the naming. So you won't be asked to name these, but you will be asked to remember the names for a few. So let's talk about the first one, which was this one. Yeah, so this here, which is CH3Cl, this is something that we call as chloromethane. Why? Because it is a methane molecule here, and when we attach a chlorine molecule here, this becomes a chloromethane. You can also call this monochloromethane. Why? Because there is only one chlorine present. So if I look down, now this one here, this is something that we call as dichloromethane. Alright, and in a similar way, the one with the 3 chlorine, these ones, We can call this trichloromethane. And the last one, the one with 4 chlorine molecules, this is called tetrachloromethane. Okay, so this is how all of this works. And the same way you can name for bromine as well. You will have bromomethane, you'll have dibromomethane, tribromomethane, and tetrabromomethane. So this is how you name for all of these molecules. And yeah, one last thing. Now, when you are in this state of, because I told you chlorine and bromines are called halogens, right? So let's take an example for this. Now, when we are reacting this thing, this is not an alkane molecule. The CH4 that we reacted at first, now this is an alkane molecule, right? This is an alkane molecule. But this here, this is not an alkane molecule. What do we call this? Because it has a halogen with it, we call this haloalkane. We say that it's derived from an alkane molecule, but it's not particularly an alkane molecule. So we call this what? We call this haloalkane. We will also call this haloalkane, right? So anywhere you have like this, yeah, this CH2Cl2. Now this is also an haloalkane. CH, where was the CHCl3? Now, yeah, this is also an alkane, sorry, haloalkane. Okay, the same way for bromine, we call that haloalkane as well. Yeah, cool. Okay.